Well, thanks for the intro, Bill, even though it wasn't recorded. You said I was a super smart guy, which I really appreciate coming from you because you've shown me so much React stuff and all this React best practices that we'll see. Some of them come from you. But this talk is a lot about Ember and about AI and generative AI in particular. And it's for working at scale. So it's working within companies, within policies, and within working code that may be legacy. And so who am I? If we haven't been at React Chicago before or have seen each other virtually, I live in Lakeview, Chicago, neighborhood, and often on the lakefront path running. I've been going to React Chicago since at least 2019, maybe 2018. And so I've had a lot of pizza downtown, watching React talks, like some of you. I like plants, running, hiking, anything active in nature. And I'm a principal software engineer at a cybersecurity company called Expel. There's also a couple people on the call who are also on that, so feel free to correct me if I say something wrong. And so just in general, what we're going to talk about today, we're going to talk about the problem first, and go over the technical solution. If I say something in the technical solution that you don't understand, we're going to go over vocab and what some of that means. Then a live demo of me calling AI models live with code that I was thinking about seeding the calls so that I would have something reproducible, but I thought it'd be more fun to potentially have it fail. So we'll see a live demo of a sample app using similar technology. Then we're going to talk about security and like working at scale with AI. And then we'll talk about Expel in particular and how we've been using it, how we're validating its use, and any questions afterwards. That sounds good. So the problem, incrementally migrate a large Ember.js app to React and Next.js. What that means is we need to maintain building Ember features potentially and be building React features and do it all while everything is working and performant. And so this was the first big problem that we had to solve. And because we're a cybersecurity company, but also because Expel is a cybersecurity company, but also just like any other small or even large company, following your data policies is extremely important. A lot of tools have access to full repos or full access to all of your code. That is kind of a non-starter for a lot of big companies. And then also follow your company's best practices around testing, code conventions, like whether you use arrow functions, single quotes, all that stuff. You can impose your own will on these things and it's a little bit easier, but I found that leaning into the company's best practices with AI is best. And so kind of lo-fi graphic, but I thought it was going to be this easy, where you tell it to do something and it's just as simple as, going from production legacy code. Everyone's been at companies where the code's 10 years old, and go with AI, find a strong enough AI, cool enough AI that all of a sudden it'll just work and then be ready to ship React. And that is not the case. And so we're going to talk about some of the reality that I've learned of taking that initial expectation, that thinking, hey, we have 100,000 lines of Ember code. Can't be work done by humans. We have to embrace artificial intelligence here and scale some of our work and our best practices. So here are some of the things that we learned. Things around prompt engineering, few-shot learning with AI, and then non-AI, but still important for this talk, is ASTs, which is abstract syntax trees, which we'll go in a little bit later. And then the last bit is sometimes easy to forget in AI discussions, but humans who understand every single line of code should be explainable. So it's reviewing by a developer who understands React as well as a developer who understands Ember, which is key. But now some background. So hopefully you're not too scared off, but if you are, we can go over some questions after we go over some background. But since this is a React conference, or React meetup, sorry, You may not know what Ember.js is. It is a full stack framework similar to a Next and React, where or I shouldn't say full stack framework, it's an opinionated framework, separates views from model and controller, just like similar React and Next.js patterns, Angular, um, comparable. And important for our talk today is it use handlebars templating library, similar to how React uses JSX. So if you see the really brutal VS Code screenshot at the bottom, it's using handlebars, and then next to it is a comparable greeting. And moving away from Ember, uh, we can use UIs like ChatGPT, similar to what I have in this screenshot, like make this Ember component hi React, and it will do a pretty good job. But you're not sure what code conventions you're going to get. It certainly doesn't scale. Doing that a bunch of times with ChatGPT would be so annoying. Copy pasting, doing certain things like that, be just so boring. And we're developers, we don't want to do boring things, but we want to control the tools we use. So we're not just using tools like magicians, wielding, AI. We're using them directly. We're customizing them. We're debugging them. And so that's what I find really important and what I find interesting about AI and engineering. So in the bottom right-hand corner, you have just a screenshot of some of the code we're going to see. All it is we're making fetch calls to AI APIs. And not just making fetch calls, but we're also doing prompt engineering. And prompt engineering has gotten a lot of hype, and a lot of people are like, oh, prompt engineers is just a job. We could just do that. But I truly think that software engineers, prompt engineering will be listed on skills, and it's not already. But it's the art and also the science of getting these models that are finicky often to do what you want to do. Something as stupid as please take your time makes a difference. And then similar to prompt engineering is few shot learning. This was a term that I learned that I didn't understand at first, but it's essentially it's like teaching a child or teaching someone, hey, here's a couple of good examples of what we want to do. Please do that. I'm going to do the dishes one time, and then you're going to watch me, and then you're going to do the dishes. As simple as that is, but it has a fancy name and some kind of conventions around it. Any questions on some of the vocab I've gone over so far? And you can put in the chat, you can raise your hand. I'm learning as well, so any questions are helpful. All good. Thanks, guys. All right, keep on going. So the next thing is abstract syntax trees. And if you've ever used regex or even tools that let you search through code, abstract syntax trees let you search through code more reliably. And so if you've ever tried to do a find and replace and you end up doing a find and replace uncommented out code, it's so annoying, right? Like if you're in VS Code, you're like, I remember one task Bill and I did, we needed to update every single import statement and every single like permutation and ordering of the statement. We went from, I think, like emotion to some other library. And we were constantly, finding like, oh, import style, comma, X, from library. And we're using tools like find and replace and keyboard shortcuts to do that. But abstract syntax trees understand the code. They parse it. They run through libraries that parse it. And then you can just use them and write tools so that these code mods are reproducible. And so you can peer review them and not just turn in a code where you turn in a pull request where you changed a bunch of things and people can't see how you did it. And so if you have to change one small thing, you'd have to redo it. I know from experience that it's not very fun. And you may have already used code mods, but just not directly, or you may have been a consumer of them rather than configuring them. ESLint uses code mods or uses abstract syntax trees to update and use rules. And JS CodeShift is a code mod library that has tools or has code transformations that you've probably used from updating like Next.js or updating React versions. Extremely powerful. and they feel like magic, but they're very straightforward under the hood. So I would really encourage you to, if you have a problem where you're constantly importing something, to use astexplorer.net. And it's a playground for you input code, and then it gives you parsers, and you can write code for that. And I'll show you some examples of it as well. Any more questions? I'm just going to pause just on these general terms. astexplorer.net is the most lo-fi website you'll see with the most utility. I can open it if we want. It's as simple as this, and you see like programs and these variable decorations. It's not anything crazy, but I would really recommend it. All right, get back. Stop mode. Cool. So now the fun bit, live demo with real AI endpoints. I'm going to share my whole screen for this, but this is what we're going to start with. And I'm just going to share my whole screen so it's easier. All right, everyone can see VS Code, and we're going to open up a window as well. Everyone sees Google Chrome and VS Code, right?
Yep.
Awesome, thanks. So I'm just going to stop this and walk through a little bit what the demo is. This is a Ember app that we're seeing on the right. And I can verify that for you. If you're not aware of Ember, I can show. Ember has dev tools just like React. And you can see these are Ember versions, and it has some state similar to React dev tools. If you're not familiar with React dev tools, I would be surprised because we're in a React meetup, but I have experienced times where I forget about this thing and need to go back to it. So definitely understandable. And because it was Halloween, I made it Halloween themed and React themed. So yeah, this is all Ember, and I'm going to be showing Ember by anything with this reddish background is Ember. And then anything in blue, which we'll see in a minute, is React. And so this is Ember inside React, and we can go into it more later, but this is around an open source of a way of using React inside of Ember. If we go to the resolver, we can see where we're searching for React components in Ember and then mapping them. Yeah, I think we copied this from this alt school example. Anyways, Ember inside of React, and we're going to start it and just look at some of the behavior. We're signing our lives away because it's around Halloween if you're watching this later, and we're signing our lives as React developers to endless cycles of prop states and re-renders and external search for a missing semicolon. You've signed it and it gets updated, so some text gets updated. And I mostly wanted a DocuSign kind of thing for lots of markdown. Sign, update, signed in blood, just a change. Anyways, all right, so now the fun part of React. I'm going to share my screen, and we're going to run npm run AI. We're going to be watching this screen for it to change to be blue, or when components are not, or when components are in React as opposed to Ember. Cool. So we see some of it has changed, right? We see this title has changed, and we can verify that because it has this React container, but we can also verify it by looking at the title that it once was handlebars. If we go to the title, once was a title and now is React. And so we have this blue, and I can walk through each step, but it's a really fun demo because it just changes in front of your face. And so I'm going to walk through the different bits of how that happened. So it's not just magic. And I'm also going to rerun this script because if you'll notice, the whole app is not AI, is not Ember yet. Uh, you can see, let's look. So this signed container, this is Ember. But if we now look inside of DevTools in React, you'll see this instruction is now React, which is really cool. And just for reference, the template that's used with that React, template React is here. And so it's just a parent component and it's rendering a React component inside of this div. And so you might be asking, how did I find which components? Why did it not migrate everything? That's where abstract syntax trees come in. So if we break down the script that I ran, where I just ran npm run AI, the first thing I did was I created template only Ember components. What this means is that if we look at the diff, we don't have components like this where there's a behavioral Ember JavaScript file that isn't really doing anything. And we found this through abstract syntax trees. We looked at the decorators here on top of this component, as well as what was inside of this class. And if you included comments in there, it wouldn't matter. And I will show you where that is. So here, this is a common example where you're traversing the abstract syntax tree. They have a lot of tree metaphors. And you're going to look at the path, the node here, and check its value. See if it's a Glimmer component there, and then check for tag name and check for class name, some other functionality that we've built. But all in all, it's checking if the component is empty. And then if it is empty, which we validated with ASTs, it's going to replace the file. And I have a few other functionality around styles, but we don't need to go into that. And it's writing files and deleting them. And the next step is, if we look there, next step in this, I was originally going to run all four in tandem, but I figured it'd be more fun to just run all in one and watch it live. So the next step would be to find the actual components to run. So if we look at this, find potential Ember components to run, we're going to be looping through all of the apps or all of the components in the app/components file. And you can see that where we found a total of 5 template only components that are available to be migrated. And those were found by looking to see again in ASTs what we're doing. So what the tags are inside of it, what is looking at. So essentially we're looking at these components from a programmatic standpoint. And if you want, I can include them in AST Explorer if people are curious of what all of these mean. But the different names and different types are different ways of understanding code. So I'm just gonna do that because this is a bit dry of a explanation. So we're gonna look at recast, handlebars, transform. I'm just gonna include a changed component in here so we could see some of what is there. We won't be transforming it, but we will just be looking at. Oh, that's not handlebars, that's JavaScript. For template babel. See what is that here? We can go to the template here. Yep, so here we go. We can see the element node types, the text nodes. And if you hover over it, you can see what it's called. I find it really helpful for learning what some of the names of these things are of these things are exactly the names of what some of this piece of syntax are, so you can more explicitly talk about it. So this is a text node, the space, and normally if you're doing a find replace, those kind of things really mess you up. But here you can find the element node and really learn from there. And so we see a mustache statement, which is something that I learned about as I was looking in AST Explorers. So that's really important how you can understand it. And if we look in here in some of these examples in the app, we'll notice that this got changed to be now React, but its parent, the signing container, is still Ember. So we could, because we can only do React inside of Ember and not React inside of Ember or React with Ember inside of it, with a parent of Ember, we have to build up like nesting dolls. And so the AST Explorer is also conscious of this. We've coded that in. And so when we rerun this, actually, it's going to update even more. So I'm just going to show you where that is. So we're finding potential update. We're just checking if it's a React component. We're checking through each element node to see if it is a React component. So it's checking if it's uppercase and checking if there is a file that exists. So it's just a lot of file handling. And so check its path, check if there is a JSX, set.jsx file. Cool. So I'm going to rerun it again. Oh, and then we can also see, sorry, the templates that we're going to change so that we did update. And we can also see in the raw output of the model. And just so you believe that I'm making a call to a real AI model, this is the Gemini model in Vertex AI. I can talk more about why this was chosen in the future for security reasons mostly, but updating that was really important and calling that. And there's no seed in here. And seeds, yeah, just make it reproducible if I wanted to really prove that something needed to be done again. And while we're in here, I'm going to talk a little bit about prompt engineering. And so that now take your time, that this makes a tangible difference, which is crazy in prompting, but it's the way the art of this matters. And so you're telling it exactly what it wants. It wants one React.js component. And similar to how we were talking about importing other components, you have to explicitly tell it. If you find an uppercase child component like fancy button, try to import it like this. You know, you're giving it exact code. Do not try to import it with one period in front of it. And so little things like that where you're saying, do this, do not do it, and give examples. Those are all really key. And similarly here, early representations were showing JSX and JavaScript, like what type of file you were outputting. So the model felt like it needed to update that. And other AI models that I tried had similar issues. All right. And so the last bit of prompting is, so this is prompt engineering. The last thing is few shot learning. And so this is where we start to get into our React and our Ember knowledge. So React developers, when we just look like this looks really wrong, right? This looks like something that should break and something that you should not do. You're having text just there, right? When I first saw this pattern, I was like, oh, that's just so ugly. Like it just bugs me. But I've come around to it, some Ember things, but this one is an interesting one where it will just render inline. Whereas in React, we're aware of React fragments, and we would render the synonymous version of this would be rendering with the two carets left and right. And if you had to import React fragment, you could if you needed a key on it. But for now, this is all you need. And because we're using the updated rendering engine, we don't have to import React. And so showing examples where you're not importing React and instructing it not to import React are really important. And so I'm just going to go through some of these, just some inline logic where you're using props with a @ symbol in front of it. and then returning inline React. Let's see, this one's exciting. So this is using if statements and conditional rendering. In React, of course, we would render like this. And based off of talking with the company and different team members, they liked this rendering of React the best. You could do this a bunch of different ways. You could do this inline. You could do all sorts of different formatting here, but through kind of rigorous dialogue and talking about it with teammates, and we settled on this. And so because we settled on this, this will scale. And some more complex. Let's see. Yeah, we want to talk about that. But yeah, just some more complex handling with props. But yeah, you want to teach it basics and then it will go. And so I'm going to call the AI model again, and we're going to see the parent components updated. You can see which templates it found. And look at that. It imported and updated the parent components properly and the inside of this component. So we could see now in this container, we see it importing the component, and it knew that, and it also updated this as well. And there's examples of using props as well here, or props in the instructions, sorry. Cool. Any questions on this demo? No. And I prompted a lot of this code itself. And in all of the examples that I was using of code, it wanted it to have this like flicker in all of it. I was like, make the code scary, make the output scary. And it just wanted to use like this flicker animation. I was like, I can't do that for our eyes. Anyways, I will get back to talking more about Expel, and I'll share just the screen. And that demo that you saw, we're going to talk about acknowledgements. But a lot of people contributed to that demo, and the AI work was complementary of that. So let's talk about Expel in particular and think about how you can apply some of this really cool technology to your company, to your day job. So Expel is a security company and takes security very seriously, as all the employees do as well. On models, all of the data had to stay inside of GCP. And in particular, if you're aware of Vertex AI, which is a service inside of GCP, they do have other models. However, at the moment, we're using only Google models because our security team has been evaluating how they share that data outside of Google, what companies look at it. They have validated with Gemini, for instance, Gemini Pro 1.52 is what we're using at the moment. And then next, you always have humans review code. So this idea that you can just use AI and just have it just send it is honestly wild. And the fact that companies want to ship that is pretty crazy. And customer IDs and components that expose proprietary app logic were excluded, and we looked at those and validated it. We also looked at IDs and looked at ways we could programmatically remove IDs with ASTs. And so now the results, 22% of template-only components were migrated, which is awesome, and exceeded my expectations. And that means 32 components, Ember components, were migrated to React. And we used a lot of groundbreaking work there and showed patterns for people who are doing manual updates to also update. And 1,500 lines of often complex Markdown and React logic, which I wish I could show you, but can't. And all of that was migrated with AI with very little human assistance on the other end. And so here's the important part that I found that I've been learning around the way is these tools can only work with what they know. And so if you can't provide full repository access, which is what a lot of the tools like what I assume Cursor and other uh, tools that are in your repository, like Copilot, they look at your whole repo when you ask them to. And that could often mean showing data that they shouldn't see. And of course, they have privacy policies, but you want your teams to verify that. And about 5% of all components were migrated, which is exciting. And we only had a couple of components that we had to exclude during the human review. And that's actually a big improvement from when I first pitched this idea to Bill. We were using an older model, and in AI terms, time moves really quickly. And this model was a few months older, and Code Bison, like the animal, was just not as good and really struggled with some of the longer components and more intense logic. And we had a much lower success rate and a lot of human intervention when we were using Code Bison. And yeah, so if the AI model doesn't know in your repository, for instance, that there's a component named, sign, like the spooky text, it won't think to import it. So you have to tell it, if you find something like this, import it and give it rules. And it can't migrate component libraries that are not migrated everywhere, which is a complex statement for saying you can't let AI do groundbreaking work in your repositories at work. If you're doing an incremental migration and there's 100 instances of using, let's say, material design, you can't in your AI migrate 50, or if it's like only an Ember library, for instance, let's say it's like Ember pluralized, you can't migrate all of those Ember pluralized because they might have different behavior than another. Sorry, there's just ambulance going on outside Chicago, per usual. And so that's really important for knowing with ASTs which to use. So if you look at the library, so if you look in here, you can notice that in here we are excluding the Ember component link to and a few other path expressions of libraries that are used. Because if we can't migrate them in one place, or if we can't only like migrate them all the way, it's not really responsible to migrate them in one place. Well, if you can't migrate them in one place, you can't. If you can't migrate them everywhere, sorry, you can't migrate them in one place. And this looks like a lot of work, but it was only done during two-day hackathons and a little cleanup work to make this presentation for you all. But you can scale code very quickly, and that 1,500 lines of code that was generated with AI can scale and learn from our experiences, and then it can only build off that. And you can get compounding approach where you saw 5 components were first migrated that were shallow, and then those parent components can be migrated as well because it knows the children is React. So this work really compounds. And so now some work you can take away. Oftentimes people think of company policies or security policies as just set in stone, not associated with any people. You just hear about these things and you have to follow them. You don't even know who sets them. But I've learned, and I would really attest this at Expel, the security folks want to talk to you. They want to hear your questions, and definitely meet with them to talk about goals before you approach this. You don't want to spend 4 weekends or a hackathon project like time working on this when you're going to get a no, or if they're like, oh, you can't use this model, but you can use all these models, and be like, oh, I've spent all this time on this particular model. Of course, it's not time wasted, but you want to use your time best when you're working within company constraints. And then question everything. Question rules with evidence and how you're getting about risk. So with the security folks at Expel, I ended up making a document that said, here's what we're going to do. This is what we're doing to avoid some of the risks that you're worried about. And this is some ways that we're helping and contributing to the code base and reducing security risk as well. So question the rules, uh, and set small goals for migrating and updating just a small part of your app, and use ASTs to do that. A lot of companies have hundreds, thousands, tens of thousands of components. I've heard billions of lines at Expel. We have 100,000 lines of components, and you can't try to migrate them all. If you put them all, you'd rack up a crazy bill, but you would also just have to deal with all that human review. It's just overwhelming. And just in terms of why I bring up cost, uh, and throughout the whole entire project, I was looking at this today, we've only spent 7 cents, which is amazing if you think of 1,500 lines of code. And so, yeah, utilize ASTs to strategize. And then another thing is work in groups. It's easier to advocate when there's a couple other people that have put in time to do this. And I find it really helpful in a company to be an advocate of AI if you can get other people to learn about it and other people to spend time on it. And so I'm really lucky at Expel. One of the reasons I like it is we get quarterly 2-day hackathons, and you can work on pretty much anything. And you can use AI with your own customizations and best practices. So what that means is in ChatGPT, there's custom instructions that you can add. So if you are using ChatGPT, you can use some of the learnings from here, where you can say, here's some of my best practices that I think about React. I want to use arrow functions. I don't want you to import React. I want you to use single quotes, things like that. You can tell ChatGPT in the custom instructions and some other tools so that every time you talk to it, you can get those best practices that you've learned and you've really honed. I used this custom instructions because I was like, this is a game changer. I'm going to use this all the time. And I was like, talk like Robin Williams. And I put it in there, and that was all I put in there, and some other React best practices. And oh my gosh, did I get so annoyed with that tone of voice, just hearing like him and like Mrs. Doubtfire, or him and everything, like explaining regex or React to me. It was really fun at first, but got so annoying quickly. But overall, use customization and don't just use the GUIs, and call the APIs directly if you can. And last, this wouldn't be possible without a ton of people at Expel and some people that have left Expel for other companies, but still, Jason Young for working on the React Ember integration, and a few other people on the team for that, and Ross and Nabil for working on the hackathon with me, Robin, my manager, for encouraging some of this work, and I want to call it Expel security team, especially Sam Brown and a few other people on there for openness and advice for what we're doing, and Expel for having quarterly hackathons, Bill for encouraging me keep on going with this stuff and to keep on working and to try to improve the amount of human intervention. And I can talk about some of the other models that I've used in a bit, but yeah, encouragement is always helpful. And then if you get nothing from this presentation, except, hey, this is cool, this slide, I think, is the most important thing that I would present. So if you have to screenshot it, go for it. I'll also be posting the presentation as well. But these courses, I can talk through each one, were extremely helpful for learning. Specifically, the first one, prompt engineering with Andrew Ng, is one of the biggest teachers in AI development, and a big founder, really good advocate. This is a short course, so it doesn't take too long, but it goes over the basics of what you need to get started with prompting and working with AI. Things like few shot learning, simple guidance. I would really recommend it. You'll use ChatGPT differently. You'll probably use Apple Intelligence differently. I still haven't used it yet. But these things are so key for just a little bit. You don't have to be an AI engineer, but a little bit goes a long way. And then the next one is ASTs, Ken C. Dodds. This is a front-end master's course, but it's all about linting. But he wrote linting plugins that use ASTs, and also is a really good explainer of how ASTs work. And then the next one are more Ember specific. People are interested in it. It's not as popular as it was. I think it's plateaued at about 200,000 downloads last I looked, which is not a lot in comparison to Next. But there's an AST workshop that talks about code transformations and JS code shift, which is applicable to React engineers. But if you are interested, this AST workshop was where a lot of this ideas got started with using ASTs in Ember and handlebars. And then Mike North is an awesome teacher. I think he's at LinkedIn, which is one of the biggest Ember users. I believe they're still using it, but he explains Ember in a way that's really easy for React developers to understand. If you wanted to go into this, a few people on the call who are work with me have learned Ember, and I would say it's tough at first because some of the conventions, but you get used to it and like some of it.